Hello, geometry lovelies. How you doing? If you are watching this video shortly after it was dropped into Google Classroom, it's right after spring break, and we are having like a whole A week, and next week will be a whole B week, and pretty soon you're going to be walking into my classroom. It's getting exciting, and shortly after that will be the end of the school year, but at least we get a little bit. So I'm glad that you're here. Happy that you clicked into this video. Let's learn a little geometry. So I'm asking you this. Is ABCD a parallelogram? Here is a parallelogram. ABCD. Is this a parallelogram? Well, right now, no. Because there's no markings that tell us whether or not it is a parallelogram. We need markings to show us. It's definitely a quadrilateral because it's got four sides, but we don't know if it's parallelogram or not. What about now? Is that a parallelogram? Yeah. That's kind of the first thing we talked about with parallelograms, is that they have to have opposite parallel sides, and that's what those markings mean. Opposite parallel sides mean, in a quadrilateral, mean that you have a parallelogram. But then the last time we talked, well, I'm getting ahead of myself. Is that a parallelogram? Yeah. Yeah, and as a matter of fact, the last time we talked, that's something that ended up being a test to see if you had a parallelogram. We got a theorem that says if both pairs of sides in a quadrilateral, which we have here, are congruent, which we have, then the quadrilateral is a parallelogram. So this is enough to say that a quadrilateral is a parallelogram. One more thing to ask you. Is that a parallelogram? Yes. The other theorem that we learned the last time we talked was if both pairs of angles in a quadrilateral, opposite angles in a quadrilateral are congruent, then the quadrilateral is a parallelogram, and that's what we have. We have a four-sided shape quadrilateral. In it, the opposite angles are congruent to one another, so therefore it's a parallelogram. So sometimes we have to be clever. Sometimes we're being told that an object is a parallelogram because it has the parallelogram symbols, the parallel symbols. Sometimes you have to dig into it a little bit and look at the sides. Sometimes you have to look at the angles. But there's a lot of different ways to talk about whether or not you have a parallelogram. And today we're going to actually talk about two more. So let's get your notes updated, and then we'll get right into that. So the essential question of the day is the fourth time that you've seen this essential question. What are the properties of parallelograms? The topic Parallelogram Theorems Part 4 is the fourth and final step down the Parallelogram Theorems road. We have broken that up into 4 parts, and we're going to be moving into something else right after this video. Make sure that topic makes it into the table of contents of your notebook, and let's do this. All right. In the last 3 lessons, we talked about 6 theorems that help us understand and calculate within parallelograms. And just like we were talking about in the warm-up, we can tell quadrilaterals are parallelograms from them. From the first 2 lessons, we know if a quadrilateral is a parallelogram, then opposite sides are congruent. We had to know it was a parallelogram first, so let's do that. If a quadrilateral is a parallelogram, then opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, which is hard to mark on a figure, and its diagonals bisect each other. So if a quadrilateral is a parallelogram, these four things are definitely true. And when you put them all on one parallelogram, it's a bit of a mess. Now, the last time we talked about how can you tell that a quadrilateral is a parallelogram? What conditions need to be met for that to be true? And we learned that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. What this means is with this shape here, this quadrilateral, that's all I need to know. And instantly I know it's a parallelogram. I don't need those parallelogram markings anymore. I just know if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Now the other thing that I also know, and I'm going to do a little bit of clever computer stuff real quick. I'm going to copy this, and then I'm going to paste it. Because the other thing that we know is basically the same thing, except instead of saying sides, we just put in angles. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. This is the two theorems that we talked about last time we were together. And you don't need both, you just need one or the other to be able to tell if an object is a parallelogram. Now we're going to learn two more. These are the final two parallelogram theorems that we're going to talk about. So this first one, opposite sides parallel and congruent theorem, is interesting. It's not really a converse of one of the others that we talked about, so it's a little bit of an odd man out kind of thing. But the basic idea in the opposite sides parallel and congruent theorem is this. If one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. Let me say that again. If one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. This is another way to tell if you have a parallelogram. If you have a four-sided shape, and within that four-sided shape, one pair, that's all it takes, one pair of opposite sides of that quadrilateral, if they're both congruent and parallel, then that thing's a parallelogram. No other things are necessary. So these parallelogram theorems, then the quadrilateral is a parallelogram theories, theorems, are kind of telling us what things do you need to know and what combinations of things do you need to know in order to know if a quadrilateral is a parallelogram. Here's the last one. The parallelogram diagonals converse. Now, one of the things that we talked about a couple of videos ago was if a quadrilateral is a parallelogram, then the diagonals bisect each other. If a quadrilateral is a parallelogram, then the diagonals bisect each other. This is just true. We can take this idea and turn it around or state its converse, and we get another way to tell if a quadrilateral is a parallelogram. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. These four theorems The 2 for this video and the 2 in the last video are basically asking you to think about what do I have, and do the things that I have tell me that I have a parallelogram. If you have both pairs of opposite sides of a quadrilateral congruent, if you know that for sure, then your quadrilateral is definitely a parallelogram. If you know about the angles and both pairs of opposite angles of a quadrilateral are congruent, then definitely that's a parallelogram. Also, if you just know about one pair of opposite sides and that pair of opposite sides is both congruent and parallel, then you definitely have a parallelogram. And the last thing, if you know about the diagonals of a quadrilateral and you know that those diagonals bisect each other, then that quadrilateral is for sure a parallelogram. The last 4 videos that, last 4 theorems that we've talked about are all tests to see if you have a parallelogram. All right, so let's work with these ideas for a sec. This doorway shown is a part of a building in England, and over time the building has leaned sideways. Explain how you know that SV, which is this side here, equals or is congruent to TU, this one over here. So that's what we're trying to figure out. So what we want to look for is ways that those two things could be congruent. So in order for SV to be equal to TU, then the opposite sides of that quadrilateral would need to be congruent. In order for those opposite sides to be congruent, it would be very handy if that shape, that quadrilateral STUV, was a parallelogram. And I have 4 different tests for finding out if a quadrilateral is a parallelogram. 1, if the opposite sides, both pairs of opposite sides are congruent. Well, I'm trying to find out one set of sides, so I don't know about both sides. The next one is, well, I know I have a parallelogram if both pairs of opposite angles are congruent, but I'm not even dealing with angles here, because that's not going to work. Then the third one, the one that we talked about first in today's video, says if opposite sides of a quadrilateral are both congruent and parallel. Congruent and parallel. Then what you have is a parallelogram. And so what we can say is this. STUV is a parallelogram because ST is congruent to VU and they are parallel. So far, so good. We know that that's a parallelogram. Well, so what? Well, in a parallelogram, opposite sides are congruent. And so what we're trying to see is if this is true. Oops, you can't see that, probably. That green showed up nicely. This is what we're trying to find out right here. But now we know that's true, because in every parallelogram, opposite sides are congruent. And so SV equals TU because STUV is a parallelogram. Just a way of kind of working through the idea. First of all, you have to show that you have a parallelogram, and the way we did that was by noticing that in this quadrilateral, opposite sides were both parallel and congruent, and from that we could tell we had a parallelogram, and in all parallelograms, opposite sides are congruent, and so that is true. All right, let's do some calculating, because that's fun. Okay, the battery died in my microphone, you guys. Okay, here we go. So, for what value of x is quadrilateral CDEF a parallelogram? Now, we know that if the opposite sides both pairs of opposite sides are congruent, then it's a parallelogram. But we don't know anything about those opposite sides. We know if both pairs of opposite angles are congruent, then that's a parallelogram. Don't know anything about that. We know if one set of sides is both, one pair of opposite sides is both congruent and parallel, then it's a parallelogram. Well, we don't know about that. The last one that we talked about was if the bisectors, if the diagonals bisect each other, then it's a parallelogram. So it looks to me like this relationship suggests that FD bisects CE, so we're in good shape. In order for this to be a parallelogram, we would need to know that FN bisects is the same distance. FN is congruent to ND, which would mean that whatever value of x made those two pieces equal would make that whole thing a parallelogram. So why don't we find out what that would be? If we took 5x minus 8 and we said, well, we want this to be equal to 3x, then we can solve for the x value that makes that happen. So let's see, what do? How about we subtract 5x from both sides? Might as well. We could do a lot of things, but that's a good start. On this side, we have negative 8 equals negative 2x. And then we can divide by negative 2 on both sides and get 4 equals x. And this is the value of x that will make quadrilateral CDEF a parallelogram. We found the value of x by setting up an equation that said, well, let's just see what happens when those two pieces are equal. Because when Fn is congruent to dn, then the bisectors of this quadrilateral, the diagonals of this quadrilateral bisect each other. And whenever the diagonals of a quadrilateral bisect each other, then that quadrilateral is a parallelogram. So all we had to do was show the value of x that was going to make those pieces equal. And that's all there is to it. So let's just kind of work with this. State the theorem that you can use to show that the quadrilateral is a parallelogram. In number 3 here, what I have are a couple of measurements in opposite sides that show me that those measurements are the same, which means this side opposite this side are congruent. So they are both congruent and parallel. So let's go back. It looks like the opposite sides parallel and congruent theorem tells us if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So we could say, oops, I'm going the wrong way, that this one is the opposite sides and parallel. Parallel theorem. I misspelled that, but you get the wrong idea. I'm using old batteries, and I'm worried that they're going to die, which is why I'm rushing a little bit. Number 4. It looks like what we have here is a quadrilateral, a 4-sided shape. What we know is that 7 inches is the same as 7 inches, and so those are congruent to one another. 5 is also congruent to 5, and so we have the opposite sides of a quadrilateral congruent to one another, which means that this quadrilateral is a parallelogram. This is the opposite sides converse theorem. Last one. Notice that 65 is the same as 65, and so these angles are congruent to one another. 115 is the same as 115, and so those angles are congruent to one another. And in every quadrilateral, if opposite pairs of angles are congruent, then the quadrilateral is a parallelogram. This is the opposite angles converse theorem. Those are the rules that tell you that each one of those objects, those quadrilaterals in numbers 3, 4, and 5, are parallelograms. All right, you guys. Whew, I think I made it to the end of this battery. I hope you have a wonderful day. Practice is in Big Ideas Math. It's called Parallelogram Theorems 4. Enjoy. Let me know if you need help, and I'll talk to you next time. Bye.